How's it going, everyone? Welcome. Eulia Gonzalez here. Today we're going to discuss about this concept that is the generators. To take a dive deep into this, which is another feature that JavaScript provides. And as we discuss that in this, when we need to handle this concurrency in our applications, we look at some of the tools that the language natively provides are not sufficient when it comes to describe is the new advancements or the new way of building modern JavaScript applications to handle now with this specific and complex asynchronous programming. So for example, tasks that overlaps at a time, we need to find a better patterns that help us to write that code in the JavaScript friendly way of doing that, which is in a sequential blocking way possible. So because of that, and at the end of the day, so far there are several tools that we can go with, especially if you're writing this concurrency asynchronous applications to deal with the concurrency in JavaScript, and callback is one of them. We also look at the trade-off of callback, which is inversion control, as well as they are not reasoned about, and how now when you need to pass a callback function or a set of instructions that will execute at some point in the future, that it generates some trust issue because you're delegating is, or you're putting them in control to run that code. So because this is true, if you are going to now use a third-party library that you're going to pass this set of instructions, you want to make sure that actually that code won't get triggered too few times, too many times, too early, too late, don't swallow errors, or don't lose context. And that's why thunks, even though that this doesn't solve the problem of inversion control, it's just a function, is a wrapper around a function that anytime you call it, you're gonna get the same value. So this will act as a token needed when we need to call this function, and we can use whatever we need in our program. So this particular token this is from the synchronous perspective, and when we look at them as from the asynchronicity, now instead of us only wrapping these functions with everything that it needs to get a value, we're going to pass a callback to this function that got everything that it needs, and by the time we want that future value, we're going to get that. And this is now why a thunk, even though that it doesn't solve the problem of inversion control, it is very important in terms of solving the problem of time in our applications. So we don't need to deal with time. However, we're passing now a callback to this thunk function, and pretty much that's it. We also look at how now thunks help us to coordinate all of this response, and how useful and how powerful it is because it combines concepts like closures. Okay, so this is something interesting. However, this doesn't solve some of the problem, especially in terms of inversion control, and with that is the trust that we need when we handle this concurrency in our applications. So promise, which is a placeholder so the promise is is the idea around. So the promise is an idea that we need some sort of placeholders, temporary value, uh, to eliminate time as a concerning factors wrapped around a value. So the thing that promise solve is that now is going to provide us a mechanism to give us control of that. It solves the inversion control, because instead of us having to pass a callback that we don't know when that will run, we effectively know that this placeholder, that this promise object, it will not resolve that or reject that future computations. So it means that you can think of this promise as an event listener, right? That by the time that they get the value, you're going to now run this particular callback. And this is huge, because now we have the certainty that these placeholders will now solve these particular trust issues when we have with inversion control. And that is not triggered too early, not too late, not too many times, not too few times, and so on and so forth. Because now this, you can think of this as a callback manager. So we looked at the promise exposed is .then and .catch, and that is events that you can subscribe. So by the time that that data is there, whether it's by the time that that data is there, you can subscribe to the .then and then extract the value, and actually is now use promise, the chainable or the tenable aspect of this, as your control flow. That's huge in terms of knowing what it's going to do and how it's going to happen, and what are the things that we need to manage behind the scenes. Because with this is the way of how we can now is not only this is also when now functional concept kicks in, for example piping, as well as the point 3, which is to look at the relationship between the function shape. And the idea here is that by having this pipe or this chainable set of instructions, you can now have, so promise is not only a flow control data structure, but also a data flow. And this is huge. This is interesting. We also look at if the promise is not resolved, we're going to subscribe to a particular event called .catch to actually is now, well, handle that case, passing a callback here. So, because with promise, there are several use cases that we need to handle in our concurring applications, such as, hey, what will happen if I want to handle only is, or I want to now handle, or I want to fulfill all of the promise, and when you receive any errors, I want you to now throw a reject promise, right? Or what happens if I want to instead now get me the first promise based on a series of promise, which is using the .race. So all of this abstraction. So for example, the promise all settles, and the subtle difference between them is that promise all say fulfill when all promise are resolved, or when any of them is rejected, right? So the other is the promise all settled is fulfill all settled promise, regardless it is fulfilled or rejected. I just want to know that. And as you can see, there is more abstractions down there that we can take advantage of. But this is something that is part of the foundation of this promise, right? So now that we have this particular problem solved, which is inversion control, we also have this tenable as a way to now change or pipe all of this set of instruction once we resolve that, all right, and also handle our errors. But by the time we want is to now understand where the monad came from, it is from the programming language called E that was made by one of the TC39 commit members called Mark Miller. Within that language, you have something called future language or future data. So here in JavaScript, we got somewhat similar to that. But again, this is a data structure. This is an object that allows us to represent this data that will come up at some point in the future. So we don't have to codify that. So it abstracts away time from a concerning factor, which is a big deal. And it also now gives us the guarantee that is once it is resolved, once it is fulfilled or rejected, we can now listen to what will happen there. So now this will provide us is a notification on when things go wrong or right. That's very powerful with promise. However, there's some trade-off of this promise. So for example, now that you have all of these tenable things, or that you have now a promise that it doesn't look like we are writing our code in a synchronous blocking fashion, the way how our brain works when we plan things, okay? And that's where we're going to explore now in today's video. So we have to take a look. We have to take a segue here about what promise is, because at the end of the day, it's a monad, and a monad is a mono is the category of end-of-functors. This is also something that I need to dive deep, but Kyle Simpson, shout out to Kyle Simpson here, actually is make it digestible. This is something that is still actually understand that. But this is a functional data structure, okay? Where the idea is to pair in data and a set of predictable behaviors that let you to interact with another data and predictable behaviors pairing, right? That allow you to interact with another monads, that another data structure. Why do we care about this, or when can we use this particular monads? Is to give us the ability to keep track state change. So because of that, all right, now we look at the usability or the use case of monads, the ability to keep track state change. And this is huge, because by the time that this promise actually receive that data at X amount of time, it will now trigger this event behind the scenes. It will now trigger is the unfulfilled, right? So in using now this monad concept, is part of the functional programming, is part of the desire of Redux, okay? This is state management to one of the design, one of the philosophy in design and the intention is that slowly but progressively introduce all of these programming functional concepts to developers so they can get familiar with and understand why are we doing this. And this is powerful in the case of state management or with Redux, because now we have is a sequential way of handling is all of this operations in a functional fashion, right? So that's why we have to also look at the async, which is now eligible. Over here, the optional. Okay, as a way to now understand that this particular data structure, and especially when we're applying now operations like map, filters, anytime we want to apply some sort of transformation to a data structure, a map, what it returns is now the data structure with all of its transformation, similar with the filter, right? And this is something interesting because this is not only applicable for arrays, but also for hash tables, binary search tree, monads, okay? Where the idea here is to understand that this particular data structure here is something that we're gonna see later on called as observable, okay? But again, this is optional. We can skip this. And then we got it. So let's gonna talk about is the generator, right? Generators. Generators. Here we go. Let's get into this. All right.
A generator is a new exotic form of function introduced in ES6. And we're going to look at the actual mechanism first, understanding some of how it works and that kind of thing. And at first, as we're looking at it, it's not going to look like this has anything at all to do with asynchronous programming. It's going to seem a bit strange and out of place. I promise there's a reason.
It's going to be seen a little bit odd and strange. And also, let me take a note of all of these words that you're doing here.
A generator is a new exotic form of.
So a generator is a new exotic, and what they call exotic is something that is newly added to the language. It's a new exotic
function introduced in ES6.
It's a new exotic function introduced in an ES6.
And we're going to look at the actual mechanism.
It's interesting. It was introduced in EX6, and we talk about that EX6 was launch date. It means that it was introduced in 2015, bro. Holy moly. June 2015. Oh my God. This is almost 10 years. 10 years to actually now understand this particular concept. And also, thanks to Kyle Simpson, to wrap around our mind around this. And this is not a coincidence here, because this course was published in 2016, bro. Holy crap, man. This course was published a year later. Holy moly. This course was published a year later. Shit. Okay.
First, understanding some of new exotic form of function introduced in ES6. And we're going to look at the actual mechanism first.
So we are going to look at the mechanism first.
Understanding some of how it works and that kind of thing.
how that works.
And at first, as we're looking at it, it's not going to look like this has anything at all to do.
Okay, so at first, when you look at it, it doesn't resemble. Did you use that?
As we're looking at it, it's not going to look like this has anything at all to do.
Okay. At first, when you look at it, it doesn't look like you have seen anything before.
With asynchronous programming, it's going to seem a bit.
Okay, with asynchronous programming. It's gonna be
strange and out of place.
It is gonna be strange and out of place. that sentence, strange and out of place.
Promise there's a reason why we're going through it. This is a fundamental part of the whole picture.
Okay, so this is a fundamental part of the whole picture.
Promises were about solving the inversion of control issue in callback hell. Generators are about solving the non-local, non-sequential reasonability problem.
Which is what happened here. So generators are about, exactly. So promise solve the inversion control problem, okay? And generators solve the non-local reasoning about that.
So they are going to provide us a really powerful version of control issue in callback hell. Generators are about solving the non-local, non-sequential reason.
Generators are about to solve the non-local, non-sequential reason about it.
Ability picture. If promises were about solving the inversion of control.
So if promises are about to solve the inversion control issue, okay, generators are about to solve the non-local, non-sequential reason about it.
Issue in callback hell. Generators are about solving the
in callback hell,
the non-local, non-sequential reasonability problem.
Generators are about to solve the non-local, non-sequential, because when you are putting all of this, especially when you put now code into your into your promise flow control, the .then, you can put functions to that. And if those functions live in other files, that actually have to jump here to another file, or look in here. So things started to become quite complicated when you handle this concurrency in your application, right? It's not how the human brain works.
Promises were about solving the inversion of control issue in callback hell. Generators are about solving the non-local, non-sequential reasonability problem.
Non-local, non-sequential reasonability. Reasonability problem.
So they are going to provide us a really powerful pattern for that. But we
So they are going to provide a really powerful pattern for that. Okay. So if a problem is about solving the Yeah, if a promise is about solving the inversion control and callback hell, generator is about to solving the non-local, non-sequential reasoning about it, the reasonability problem.
We need to understand, we need to kind of walk through the plumbing of this stuff to understand how it's working. Are going to provide us a really powerful pattern for that. But we need to understand, we need to kind of walk through the plumbing of this stuff to understand.
So we need to understand the plumbing. I love that word. I love that word. Plumbing. I love that word, bro. The plumbing. The plumbing, bro. That's very interesting. So we need to understand the plumbing.
Understand how it's working.
So we need to understand the plumbing of how that's working. I really love that word, man. I definitely love that word,
man. One of the things that you may not have ever realized about your assumptions with JavaScript is that all functions, all normal functions, have a characteristic of them, which the fancy way of saying it is that they have a run to completion semantic.
Okay. So all functions, all functions have this fancy terms of run to completion.
What that means is that when a function starts running, it will always run to the end of that function and finish before any other function has an opportunity to come in and start running.
So what it means is that any time a function is calling, if a function is called, it will execute it top to bottom.
At any given function starts running, it will always run to the end of that function and finish.
So it will execute it until the end of that function. Exactly, it will execute until the end of that function before it will execute it
before any other function has an opportunity to.
Before any other function have the opportunity to run it.
To come in and start running. At any given.
Or to come in and start running.
Moment only one function is actively executing. That doesn't mean it can't call to other functions, but it means that nobody can come in and preemptively
and at certain that doesn't mean that so that doesn't mean that that doesn't mean that the opportunity to come in and start running. So that doesn't mean that that doesn't mean that stopping us from calling more function.
Interrupt this function to run something else.
It is that no one can interrupt this function. Is that no one can interrupt this function in the middle.
Executing. That doesn't mean it can't call to other functions, but it means that nobody can come in and preemptively interrupt this function to run something else.
Exactly. It is that no one can interrupt this function to run something.
To run to completion. That doesn't mean it can't call to other functions, but it means that nobody can come in and preemptively interrupt this function to run something else.
Preemptively. What in the... Okay, no one can preemptively. Okay. Okay, calling more function is that no one can preemptively interrupt this function. Preemptively. Interesting. You're learning vocabulary, bro. Preemptively.
Executing. That doesn't mean it can't call to other functions, but it means that nobody can come in and preemptively interrupt this function to run something else.
Is that no one can preemptively interrupt this function to run something else. Okay, run to completion. Is that no one can preemptively no one can preemptively interrupt this function to run something else.
It's a run to completion semantic. And that may seem like very, academic in nature, but it's actually one of the most important characteristics of JavaScript. It's what allows us to reason about things in a single-threaded fashion, never having to worry about two functions, one interrupting the other one and corrupting our shared memory.
This is, despite that sounds pretty academic, it is very important concept since we don't have to deal with multiple functions running at the same time, sharing memory or corrupting it.
Ways that we don't understand. All the problems that you have to deal with in threaded programming get introduced when you don't have that run to completion semantic.
Sharing memory or corrupting it. And all of these concepts from multi-threading programming, needed when you don't have these concepts of run to completion.
So it's one of the most fundamental things that we've built all of our understanding on JavaScript. So that might raise a few warning flags in your head when I tell you generators do not have a run to completion semantic. They're in a different kind of function altogether. It's a very different kind of beast. Now that's not designed to introduce chaos into your program. It's designed to introduce a behavior that we previously had to go to a lot of work to simulate. So it's adding a syntax.
Okay. So generators, since generators are not run to completion. Okay. So generators are not run to completions. So they are not designed to bring chaos to our program. But so they are not designed to bring chaos to our programs, but to solve a particular issue or to solve a problem, a particular pattern.
It's designed to introduce a behavior that we
Okay. is designed to introduce a behavior that previously was pretty hard to do it.
Previously had to go to a lot of work to simulate.
Where previously you have to do a lot of work to simulate.
So it's adding a syntactic sugar, if you will, on top of a behavior that we would have had to spend quite a bit of time and effort to try to emulate. Okay?
So it is a syntactic sugar. No. Syntactic. It is a syntactic sugar of a behavior that we need to put a lot of work to emulate.
So the thing that we are attempting to create with the syntax of a generator, by the way, JavaScript didn't invent generators, they come from other languages like Python, but the thing that we're trying to create with the
Okay, so generators comes from Python, and this is interesting because all of these languages are now sharing stuff and trying to add it to this. So generators come from Python, okay, run to completion. And now promise comes from programming the programming language E to now handle this future values or these placeholders that allows to eliminate time as a concerning factor wrapping around a value. Similar now for the case of React and Vue and Svelte and Angular, where they are shuffling and sharing is all of these particularly patterns and concepts. Okay. Actually, to introduce behaviors, which is exactly what they're doing. They're introducing behaviors to come to solve the specific problems that it requires a lot of work to do that. So now this is a pattern.
JavaScript generator is a syntactic form of declaring a state machine. State machines are to create with the JavaScript generator is a syntactic form.
The JavaScript generator is a syntactic form of describing a state machine.
Of declaring a state machine. State machines are, for those of you that aren't aware, a way of having a patterned series of flow from one state to another state to another state.
Is a so state machines is a pattern for having a state after state after state.
And state machines are, for those of you that aren't aware, a way of having a patterned series of
state machines, for those who are not aware, like me, who are not aware. I mean, it required time to explain that, which is, you don't know. you don't truly know. That's what happened. So state machines, for those who are not aware of,
flow of declaring a state machine. State machines are, for those of you that aren't aware, a way of having a patterned series of flow from one state to another state to another state.
Patterns of series of flow.
And state machines are, for for those of you that aren't aware, a way of having a patterned series of flow from.
It is a way to have a pattern of series of flows, a pattern of having a series
one
of
state
flows
to another state to another state, and declaratively listing all those states and those transitions out. Patterned series of flow from one state to another state to another state.
It's a way to have a pattern of series of flow from one state to another state,
and declaratively listing all those states and those transitions out.
To another state, and declarative listed all of this, and declarative listed all of this
series of flow from one state to another state to another state, and declaratively listing all those states and those transitions out.
Listed all of this transition out, and listed all of this transitions out. But again, from one state to another state to another state, and this is a pattern of a series of flows from one. Okay, this is a pattern of series of flow from one state to another 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 state, and the declarative listed. And the declarative listed all the transactions out. This one and this one and this one and this one and this one. State machines is a way to have a pattern of series of flows. A pattern of series of flow from one state to another state to another state.
So we can implement state machines without generators, and I've done that many times. Some of you may have implemented your own state machines, but you have to go to a lot of work, and you have to end up using closure around a function to remember the state as it gets recalled over and over again.
So trying to implement this pattern using callbacks and iterators is something that requires a lot of work.
And each time it's recalled, it remembers its previous state and it does the transition. So it's possible.
So anytime it is called, it remembers its previous state. Anytime it is called, it remembers its previous state.
But around a function to remember the state as it gets recalled over and over again, and each time it's recalled, it remembers its previous state and it does the transition. So it's possible, but
so anytime it is called, it remembers its previous state. It is possible, but it requires a lot of work.
But it's harder and it's a lot less clear what's going on.
It's possible, but it is harder and it is less clear of what's going on.
A generator is a syntactic form of a state machine.
So a generator is a syntactic form of a state machine.
And while that won't seem like that has anything to do with asynchronous programming, it's actually a magical key that will unlock one of our really important characteristics that we're going for. So to get there, we want to start looking right at the very beginning at generators. And what we're going to see is that there's this new special keyword called yield. The yield keyword is kind of like the pause button on an old school VC.
And so this will give us the magic key needed to solve this non-local, non-sequential, non-local, non-sequential, because after all, this is a pattern of a series of a series of flow control, or a series of flows from one state to another state to another state to another state to another state, and it make it and listed all of the transition outs. Okay. So I generated a syntactic form of state machines. So this state machine, I want you to do this, and then I go this, and then I go that, and then the state machine is a, and then the state machine is a, and the state machine is a pattern, or the state machine is a way. It's a way. Okay. And then a state machine is a way to have a pattern. Interesting. And then a state machine is a way to have a, and then a state machine is a way to have a pattern. Okay. Okay. And then a state machine is a way to have a pattern. Holy crap. Yep. And then a state machine is a way to have a pattern of a series of flows from one state. It's a pattern to have a series of flow from one state. It's a pattern. It's a way to have a pattern. Okay. So it's a way to have a pattern of a series of flows from one state to another state to another state to another state to another state. It's a way of having a pattern. But it's a way of having a pattern of a series of flows. All right. And this series of flows, it can be now is, hey, I want you to, this will be the, for example, in a user application, you might have is the user login, the user checkout, the user flow control. The user login, the user reset password, the user check their profile, the user flow of buying a product. Okay, so all of these different states, this is interesting. This series of, a way of having a series of flows. Holy moly. A way of having a series of flows is a way of having a pattern of series of flows. That's why, for example, tools like XState, okay, they are heavily based on that, on generators, by the way. XState is a state management and orchestration solution for JavaScript and TypeScript apps. It has zero dependency and it is useful for front-end and back-end applications logic. Again, because the one who have the most popularity for this is Redux, because Redux comes first. So Redux launch date 2015. Okay, so Redux coming in 2015 and React in 2013, and because this concept, that fucking hell, bro. And because of that, now and because of the ES6 was launched nearly that moment, EX6 launch June. It's June. So now they have adopted, they have evolved with the languages here. Okay. And this is XState. Persisting serverless state machine with xstate and restate. Oh, this is too early, bro. Again, this is for companies, bro. This is for big companies. This is for big companies. 2018. Now it have to wait 10 years more, or at least 5 years more, to 2023. We'll say 5 years more. Yeah, you have to wait like to become trendy. Yeah, to become trendy, bro. 2023. Interesting. Clinical operations. Interesting. Okay. All right. So this is like plumbing. So we need to take a look at the plumbing and the mechanism to understand how that works. But the problem here that is, if promise is all about solving the callback hell and the inversion of control, now we understand what is the problem that they're solving. Generator is all about so generators are about to solve the non-local, non-sequential reasonability problem. Okay.
CR. You're watching a movie and you click the pause button. Literally pauses right in mid-frame, nothing changes, and you can wait as long as you want to. It's kind of like the pause button on an old school VCR. You're watching a movie.
So it is kind of like pausing a video in a VCR. Jesus. VCR, man. It's kind of like pausing a video in a VCR. Stop the execution here.
And you click the pause button. Literally pauses right in mid-frame, nothing changes, and you can wait as long as you want to.
So it's kind of like pausing a video in a VCR or YouTube. You can it stop there at that frame. You can wait as much as you want, and when you hit the play button,
and then you can come along later and press the play button and
Mm-hmm. And then you can come back later and press the play button to resume.
Resume.
Mm-hmm. To resume. Resume. Okay. Mm-hmm.
So you can think of a generator as a pausable function. A function that when it's running,
so you can think of a function of a generator as a function that pause.
would run across a yield keyword, and at that moment,
Will pause when it find out the yield keyword. Okay, you can think of generator as a function that pause when it find out the yield keyword.
Wherever the yield keyword shows up, even right in the middle of an expression, everything just literally freezes, it pauses. And the generator enters this paused.
Even in the middle of an expression.
State. Even right in the middle of an expression, everything just literally freezes, it pauses. And the generator enters this paused state.
In this, there's a function that pauses when you will find the yield keyword, even in the middle of expressions. Everything is freeze and pause it.
And it will wait for that pause state indefinitely.
Names, and it will wait for that pause state indefinitely. Indefinitely. Okay. Indefinitely. Definitely. Indefinitely. It's because I got some trouble here to the right is the word definitely. Okay, or definitely because it's this indefinitely. I barely write this word, that's what happens. So indefinitely, or definitely, define, but in this case define definitely, definitely, interesting. And we'll wait for that pause indefinitely
until some other actor comes along and says, it's time to resume.
And until some actor comes here and say it is time to resume.
And they press the play button again. So you can think about a generator as a function that can pause and resume,
So you can think of a generator that is a function that pause and resume until it reach the end.
As many times as necessary. While a generator is paused, on the
Okay, as many times is necessary.
inside of the generator, pause and resume as many times as necessary. While a generator is paused, on the inside of the generator, everything is completely blocked. Nothing is happening. But that's not blocking the overall program, it's a localized blocking, only inside of the generator. That's a really key issue. So even though what I'm about to show you will look like we're creating a blocking sort of a thing, it's extremely localized. It's not blocking the entire program. So here's an example of it I'm about to show you will look, but that's not blocking the overall program, it's a localized blocking. Inside of the generator, everything is completely blocked. Nothing is happening as necessary. While a generator is paused, on the inside of the generator.
So while the generator is paused, on the inside, everything is blocked.
Everything is completely blocked. Nothing is happening. But that's not blocking the overall program, it's a localized blocking.
It is a localized blocking, not the entire program.
Only inside of the generator.
How
really
that
key
blocking
issue. So even though what I'm about to
works.
show you will look like we're creating a blocking sort of a thing, it's extremely localized. It's not blocking the entire program. So here's an example of a generator. You'll notice on line 1, we have that little star symbol there because we need to introduce a different kind of function with a different set of behavior to it. So there needs to be a syntactic clue to the engine. This is a different sort of a thing. So it's function star. That's how we indicate that it's a generator. You'll notice on line 3 that we have the yield keyword there. And that yield keyword is the pause button. So it's like the generator. The generator gets to decide when it wants to pause. Nobody on the outside gets to tell the generator when to pause, so it cannot be preemptively interrupted. This is what we call cooperative concurrency rather than preemptive concurrency. So preemptive means somebody else on the outside. We have the yield keyword there, and that yield keyword is the pause button. So it's like the generator gets to decide when it wants to pause. Nobody on the outside gets to tell the generator when to pause.
So we have control about when can we pause here. No one on the outside will.
Cannot be preemptively interrupted. This is what we call cooperative concurrency rather than preemptive concurrency. So preemptive means somebody else on the outside, some outside force can come in and interrupt you at any given moment. That's the thing that causes chaos and havoc in threaded languages. We don't have that. What we have is that the generator gets to decide by virtue of calling a yield keyword when and where and in what manner it wants to yield itself, when it wants to pause itself. Now, another thing that's different about a generator from the aesthetic usage perspective, on line 7, when I call GEN, I'm calling what normally looks like just executing a function. And we typically, like the generator gets to decide when it wants to the engine. This is a different sort of a thing. So it's function star. That's how we indicate that it's a generator. You'll notice on line 3 that we have the yield keyword there. And that yield keyword is the pause button. So it's like the generator gets to decide when it wants to pause. Nobody on the outside gets to tell the generator when to pause. So it cannot be preemptively interrupted.
So no one on the outside can preemptively okay. So no, similar for the similar to preemptively preemptively and that particular word, which is indefinitely, exactly, indefinitely, emptifully. Anytime you're gonna use this easily, all right, you put it like e here. Okay, indefinitely, preemptively. Okay. So no one on the outside can preemptively interrupt the execution of this function.
This is what we call cooperative concurrency rather than preemptive concurrency. So preemptive means somebody else on the outside, someone outside.
So this is what we call cooperative concurrency.
Force, what we call cooperative concurrency rather than preemptive.
Cooperative concurrency rather than preemptively concurrency. Preemptively concurrency. So no one on the outside can preemptively interrupt the execution of this program and run something. This is now known as cooperate here. Concurrency. Okay.
Concurrency. So preemptive means somebody else on the outside, some outside force can come in and interrupt you at any given moment. That's the thing that causes chaos and havoc in threaded languages. We don't have that. What we have is that the generator gets to decide by virtue of calling a yield keyword when and where and in what manner it wants to yield itself, when it wants to pause itself. Now, another thing that's different about a generator from the aesthetic usage perspective, on line 7, when I call GEN, I'm calling what normally looks like just executing a function, and we typically would expect for it to execute the whole thing, but actually none of the generator runs at that point. Executing a generator does not actually run any of its code. Instead, it produces an iterator.
So line 7, instead of producing is a function, it produces a iterator, which is a concept.
Some of you hopefully have heard about iterators. Iterators are a patterned way of stepping through, typically stepping through a set of data.
Okay. It produces an iterator. So it is a design pattern. It is a pattern for stepping through meaning. Stepping is the act of walking. Stepping through. Interesting. Stepping through is an idiom that means to become familiar with a process or job by following a step-by-step demonstration. Stepping through. To process or move forward by taking one step at a time, often in a systematic and careful manner. Step through. Step through. Paso a paso. Step through. Interesting. Paso a paso, mano. Step through. Paso a paso. All right. Stepping through a data structure.
Like, for example, some of you hopefully have heard about iterators. Iterators are a patterned way of stepping through, typically stepping through a set of data.
It's a pattern for stepping through typically a set of data. Okay, so going over to this particular data sets in a sequential and systematic way. So regardless of the data structure, we can now use this pattern as a way to stepping through all of those elements, right? So whether it's an array or a hash or a binary tree or a monad as well.
Like, for example, the results from a database query. You would step through them one result at a time. Iterators are a patterned way of stepping through, typically stepping through a set of data. Like, for example, the results from a database query. You would step through them one result at a time. You'd call .next, 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 and keep getting value results from a list until there were no results to come back. That's the iterator pattern. Through them one result at a time. You'd call iterators are a patterned way of stepping through, typically stepping through a set of data. Like, for example, the results from a database query.
For example, the result of a database query.
You would step through them one result at a time. You'd call.
For example, the result of a database query. You can step through at a time.
Call .next, 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 and keep getting value.
So you can step through at a time, which is something that I'm not familiar with databases. What happened? So for example, the result of a database query, you can step through at a time and keep calling the .next function until exhaustion or until the end.
Results from a list until there were no results to come back. That's the iterator pattern. And iterators are something that we've been able to do ourselves in JavaScript for a long time, but they've now been added directly as first-class citizens to the language. We can create our own, and we can use generators that are produced by other mechanisms. Ourselves in JavaScript for a long time, but they've now been added directly as first-class citizens to the language. We can create our own, and we can use generators.
In JavaScript, okay, we have to make our own interest. Jesus. In JavaScript, we have to make our own. Holy crap. Yep. So in JavaScript, we have to make our own iterators by hands. But now with generators, we can have them. But now with generator, we can have them as first class citizens.
That are produced by other mechanisms. In this case, calling a generator.
Produced by other mechanisms. So in JavaScript, we have to make our own iterators by hand, but now we can have them as first-class citizens produced by other mechanisms, like generators.
Generator produces an iterator. And the purpose of the iterator in this case is not to step through data, but rather to step through.
Exactly. And the purpose of these generators is not to step through data, is to step to a function execution.
Through the control of our generator from the outside. So again, we can't pause the generator, but we can ask the generator to run until it wants to pause, and control of our generator from the outside. Iterator. And the purpose of the iterator in this case is not to.
And the purpose of this iterator in this case is not to stepping through data, but through the function execution, and in this case to the generator flow control.
To step through data, but rather to step through the control of our generator from the.
It's not stepping through the data, rather to the control of the generator flow, bro.
The outside is an iterator. And the purpose of the iterator in this case is not to step through data, but rather to step through the control of our generator from the outside.
Rather to the control of the generator from the outside.
So again, we can't pause the generator, but we can ask the generator to run until it wants to pause, and then when we call .next again, we.
Exactly. So we can stop our generators, but we can run until it is stopped and call
and resume it, and then it'll pause again, and we can call dot.
But we can run until it is stopped. We resume it. It pause.
Again, we can't pause the generator, but we can ask the generator to run until it wants to pause, and then when we call .next again, we can resume it, and then it'll pause again, and we can call .next, and it'll resume, and then it'll pause again. So here on line 7, run until it wants to pause, and then when we call .next again, generator from the outside. So again, we can't pause the generator, but we can ask the generator to run.
Exactly. We can pause the generator, but we can ask to run
until it wants to pause.
Exactly, but we can ask to run until it pauses.
And then when we call .next again, we can.
And then it'll pause, and then we call the .next again, running until it pauses.
Resume it, and then it'll pause again, and we can call again. We can't pause the generator, but we can ask the generator to run until it wants to pause, and then when we call .next again, we can resume it.
And then we call .next again to resume it and pause.
And then it'll pause again.
To resume it, and then it'll pause again. Call it .next.
We can call .next, and it'll.
Call the .next. Call the .net. Resume and pause it again.
Resume, and then it'll pause again. So here on line 7, when I call GEN, none of the codes run. But on line 8, when I call the first .next call, I start it up on line 2, and I start running the generator. So I'm going to print out the hello that you see there. And when it gets to the yield keyword on line 3, it's going to pause and return control back to line 8. The line 8 could then proceed immediately to line 9 and call .next again and resume it. So you can synchronously step through it. But of course, there could be a break. There could be a gap. There could be a delay in time between lines 8 and 9. And in that period of time, the overall program continues to run without change. But what's different is that inside of this generator, it's in this paused state. It's blocking, it's waiting for somebody to come along and call the .next method again to resume it. This is going to feel strange and bizarre to those of you that haven't worked with generators before. So just like everything else, what I'm suggesting to you is not in 5 minutes you're going to be an expert on this pattern, but I'm trying to suggest to you, if you trust me at all, trust me that this is where you should spend a whole bunch of time thinking and practicing and reading, because it's going to change everything that we do with asynchronous programming. I'm 100% convinced it's one of the most revolutionary changes to our language. That's why we spend time thinking about it. Okay, so if we can pause a generator while it's running, it's also message passing. So here, I'm not just calling yield, but I'm actually calling yield with a value. In the previous case, when I showed no value in the yield expression, it was assumed that I was yielding undefined. But here I'm yielding actual values like 1, 2, and 3. And you notice that when I call yield 1, I return control back to line 9 by way of returning a value. So .next returns us an object that has 2 properties on it. It has a value property with the value that was yielded, if any, and it has a done property that tells us true or false, is the generator complete. So that's why we get value 1 done false. And then we can call .next again right away or at some later time, and we're going to get value 2 done false. And then we're going to call it again, and yield 3, at that moment it kind of looks to you visually like the generator is done, but it's not really done. That's why we still get done false, because technically it's paused on that last expression. Even though visually we can look at the generator and say it's not going to do anything else, technically it's still paused. Technically you can still do something with it. So that's why the fourth .next down there on line 13 would resume the generator at the paused line 4. Immediately there's nothing else to do. It would finish, it would complete, and then we would get an object back that there was no value given to us, but there was a done true. Now what about that?
So because this is a way of how you can describe, because it is a way to describe behavior, because the whole point of this is that the whole point of this generator, okay, they're not going to design to bring chaos to your program. It introduces a behavior that previously we have to do a lot of work to simulate that. And it's syntactical sugar of the behavior that we need to put a lot of work to simulate. So this comes from Python, and this is an state machines, right? So this is a syntactically, so in JavaScript, generators is a syntactic form of describing a state machine. And for those who are not aware of, it is a way of have a pattern of a series flows. It is a way of have a pattern of a series of flows from one state to another state to another state to another state to another state, and describing a list of all of this transition. So generators allows us to describe all of these different states. Interesting. All of this series of flow from one state to another state to another state to another state, and listed all of this, and listed all of the transaction, and listed all of these transactions out. So in the context here on JavaScript, this generator, which is a state machine, that we can say, hey, in this particular state, I want you to be here, and then another state here, and another state here, and another state here. So we are now this will unlock this magical things of having this to solving the non-sequential, non-local reasoning issue, right? Because pretty much like here, this function that is not generating is a function. These generators is, in fact, you can think of this like a pausing a video on a VCR or YouTube. So you press the button, and then that stop at that particular frame, it freeze, and you wanna and it will wait as much as you can until you come back and press that button to resume it. So you can think of these generators as this function that pauses as this function that pauses when it finds the yield keyword, and it can be in the middle of the expressions, and it's everything in there is freeze, pause, and it will wait indefinitely until some actors coming in say, hey, it is time to resume. So you can think of generators as this function that pause and resume, pause and resumes, pause and resumes as many times necessary. As many times as necessary. So this is now generate is this so no one preemptively interrupt the execution of this function. And by preemptively meaning is that no one can preemptively interrupt this execution of this function with some new functions. This is known as cooperative concurrency, rather than preemptively concurrency. Hey, I'm gonna preemptively doing this kind of things, but here is not. This is cooperative concurrency. And the way now here in JavaScript, we can make through this. So this is pattern. This pattern it produces here, like in line 7. So instead of actually calling it a function and generating, provide us a function, it now going to produce is the iterators. And for those who are not familiar with iterators is just a pattern for stepping through a data set. So pretty much like querying in a database, when you can step through at a time and calling next function till the end, until you get all of this list of elements. In JavaScript, iterators is something that we have to do by our hands. This to write this particular pattern as a way to now hold the state here, because now we need to make sure that, hey, we want to hold the state, and by the time that this function is being called, we update the state properly, and we show the proper transactions and that kind of thing. So it required careful programming here. So now here we have now this iterator as our first class citizen. So instead of stepping through a data set, we're going to stepping through is on the control of a generator. Okay. So the purpose of iterator is in this case is not step through data, rather to the control of the generators from the outside. So we can stop our generators, but we can ask to run until it pause then, and we call with the next function to resume, and then it'll pause again. Call it with the next with the .NET functions, resumes, and pause it again. Jesus. Okay, and it is worthwhile to actually take the time to understand how this concept conceptually be able to describe that. Okay, all right, that'll be all for this video. Take care. Bye-bye.